Hi, it's Carly McAvoy. Today I want to show you how to factor, especially when you're told to factor completely. That's usually a hint that there's more than one factoring process required or one method required. So we're going to look at the 5 examples that are at the top. Feel free to cruise down into the video to find the one that you want to see. In the first one, I have a trinomial. And I can see that the common factor is 3 because I have 3 in each one. But I can also see that each term has at least one n. So when you take out a common factor, it's not just a number. Sometimes it can also be a variable. So we're going to factor out the 3n. And when we say that, factor it out, we're saying divide each term by that. So we're going to divide each of our original terms by 3n. And then you have to use rules for exponents. But 6 divided by 3 is 2, and then I have 3 n's on top and 1 on bottom. So when those cancel out, I'm going to have 2 left. Here, when I have 2 on top and 1 on bottom, I'm going to have 1 left on the top. And over here, these n's are going to cancel completely. I won't have any n's left. And the 3's also cancel completely, but I don't have 0 there. What I have there is 1. So I have to remember that when I finish factoring, I can go back and multiply back through and get what I started with. So I can't just say, oh, we're just going to drop 3 in and make that nothing there. No, that's going to become 1 so that when I multiply this out, -1 times 3n would bring me back to that -3n. This particular problem, you could try it if you wanted to try to factor it, but this one doesn't factor any further. This one, all you can do is factor out that common factor, and that's it. Okay, in the second one, we have just 2 terms. And when we have 2 terms, we typically do think about a difference of squares. But before I do that, I want to say, is there a common factor? And I can see that there's a common factor of 4. I'm going to take both those terms and divide by 4. And that's going to leave x squared minus 1 in the middle. Again, 4 divided by 4 is not 0, it's 1, so I still have that there. And I could go back and say 4 times x squared, that's 4x squared. 4 times -1 is -4. So I'm not losing anything. Factoring is just rewriting something as a multiplication problem. It's not getting rid of terms here. Okay, so now this is a difference of squares. Because this is a perfect square, x squared is x times x. And 1 is a perfect square because 1 times 1 is 1. So when you do that, when you break down a perfect square, and this is not a video teaching you how to do the difference of squares. This is just showing you what to do when you have to factor twice. So I will just say what happens is this minus becomes a minus and a plus. And your first term, x squared, breaks down into those first 2 spots. That's x times x. And the second term goes into the second 2 spots. That's 1 times 1. If you were to multiply this out, you would see that your inside terms are positive 1x and your outside terms are negative 1x, which means we don't have a middle term. We just have those 2 terms, the square of the first term and the square of the last term. It has to be a minus in there for that to work. That's why it's called a difference of squares. Okay, we can't factor any of that any further, so our answer is the 4 and then the x plus 1, x minus 1. I don't ever want to get rid of that thing I factored out. I want to keep that. Okay, for the third example, we have 4 terms. Typically, when we're thinking of 4 terms, we are thinking of factor by grouping. So that's what we're going to do here. But first, I can see that there is a 5 in every term. I can also see that these 2 terms have an x and these 2 terms have a y. But what I'm interested in is what's something that goes into all the terms, and that is 5. So I'm going to divide every term by 5. And the 5 was left outside. If I was to go back and distribute 5, I could get back to what I started with, 5x, -40y, etc. And now I can see that I have common factors in these 2. I can see that they have an x. I can see that these 2 both have a -4. So I can move on with this problem doing factor by grouping. Factor by grouping is what you do when you have like 4 terms and you want to try to factor it. Say, sometimes you have to rearrange. I'm not going to rearrange these. I'm going to do them exactly as I was thinking. That 5 is still outside. But what I've done is I've grouped these 4 terms in the middle. And I want to be careful because when I do factor by grouping, in between my 2 factors should be a plus. So I have the 2xy plus x. Then I have a plus. That minus sign, that just goes to the 8y. So that goes inside the parentheses with the 8y, -8y minus 4. If I put the negative out front, that would change everything. I don't want that to happen. So I want to make sure I put a plus in there and bring that third term has its own sign. Now I can see that this first part has a common factor of x, and the second one has a common factor of -4. I always want to get rid of a negative in the lead spot if I have one. So if I take the x out of here, and I'm taking it out by dividing like I did up above, I have 2y plus 1 left. Remember, x over x is going to be 1. And over here, if I take out -4, I'm dividing this term by -4 and -4 by -4, which gives me plus 1. And now I can see that 2y plus 1 are common factors. So now I'm going to take out that 2y plus 1 and put it in front. And what I have left from the first term is the x. And from that second term is the -4. I still have the 5 out front. Now that can't be factored any further. So that is going to be your final answer for that problem. Okay, moving on. We have 2 trinomials left. For number 4, I can see that this has a common factor of 2. So I'm going to factor 2 out, and when I factor 2 out, meaning I am dividing everything by 2, that leaves x squared minus 4x minus 45. Now I have a trinomial. You should factor your trinomial in whatever method you love. I love the box method. That's what I'm going to use. And I have to remember when I'm finished that I need to have the 2 out front because I don't want to drop that. I'm going to have 2 and then followed by 2 sets of parentheses. I'm not just going to have this and act like the 2 never happened because that's part of my answer. So the box method, you make 4 boxes. Your first term, x squares, go over the first column. I have 2 videos on box method that you can watch if you don't know how to use it. This is really not a video about how to use the box method, but I am using it. So that I have -45 that goes here, and my middle term goes down below. And I know this is going to be x times x. There's no other way to multiply 2 things to get x squared. But these 2 boxes need to multiply to be -45. And the factors of 45 are 1 times 45, 3 times 15, and 5 times 9. Looking down here, I can see that I want 4. Well, I'm never going to get to 4 here or here. But if I use 5 and 9, I could get to 4. So I'm going to use the factors 5 and 9 for this problem. So in my next step, then I go, okay, x squared has to be x times x. If you multiply x times x, you get x squared. -45, there's going to be 1 negative and 1 positive. I made the 9 negative and the 5 positive. Why did I do that? If I multiply straight across, I get -9x, +5x. And adding those together gives me a -4x. If I had made the 5 negative, I would get +4x. So I want to make sure that this term down the bottom is correct. And then remember that your answer is always on the diagonal. So this would be x minus 9 and x plus 5. It doesn't really matter in this problem, but it will in others. So just remember to get into that habit. 2 goes out front, and there's your 2 terms. Finally, I'm going to take the common factor of 7 out of this last one. This has it has 2 different variables in it. We can still use the box method for that. Similar to before, I'm going to put the first term over the first column, the last term over the last column, and that middle term down below. It is positive GN, which means +1 GN, right? I always put the sign, whether it's plus or minus. And then there's no options here. -n squared has to be -n times n. But I do have some factors of 6 to consider, 1 times 6 or 2 times 3. This has to come out to be 1. These are 5 apart. That's never going to work. It's going to have to be the 2 and the 3 that I use. And so I'm going to put 2g and 3g. And if I multiply straight across, I get -2g and +3gn, sorry. And if I add those together, I have 3 positives and 2 negatives, which makes a positive. So it does matter. I couldn't put 3g on top and get -3gn because I need more positives. I need that positive to be bigger number, and then the negative to be the lesser number. And then I'm going to take my answer off the diagonal, 3g minus n, 2g plus n, and I'm going to remember that I took out that common factor of 7, and that would be my final answer. Thanks, and have a great day.